Alrighty, it seems like most people are in, so welcome again. Thank you so much for joining us on the first one of these talks for the year. They are run by the Live Project, which I am part of, in collaboration with the Kerry International Dark Sky Reserve, and we're delighted to be continuing them this year. Someone has their hand up there, Anna. Do you mean to have your hand up? Would you like to put something in the chat? Or is that an accident? So what I was going to say, and Anna, you're welcome to talk. First of all, is Nullag Naman Huna Yiv. And if there are ladies joining us in the audience tonight, which it looks like there are quite a few, I hope you have your feet up and you're drinking tea that someone else made you for the evening that's in it. And just a little reminder that we can't see or hear you, so you can shout at us or tell us we're wrong or anything you want, and we won't know. But if you would like to join the conversation, please do. Please use the chat or Q&A functions. Make sure if you're in the chat that you're writing to all participants. And please also do feel free to raise your hand if you have a question, and we can allow you to speak as well afterwards in the Q&A. Orla's just putting some comments into the chat there, and she might do that throughout if there's anything that needs that we need to be reminded of, little links or anything like that. As always, the session is being recorded and it will be available on our YouTube channel and website afterwards. And we have a really nice pair of speakers this evening. So I will hand you over to Steve Lynott of Kerry Dark Sky Tourism, who will introduce our speakers and kick things off.
Thank you very much, Lucy, and again to our own two ladies, Lucy and Orla, Nullag Naman, Women's Christmas, a big tradition in Kerry. In days past, no man would have suggested watching a computer screen tonight. He'd be too busy either cooking for his lady or taking her out somewhere. So happy Nullag Naman, Women's Christmas. And thank you as ever to Orla and Lucy for their help and support. We have a very interesting session for you today, and a bit of an international flair. John has flown in from America for tonight, and our other speaker, Ben Porter, whom I'll introduce later, is joining us from Wales. So we have people from Dublin via New York and San Francisco, Wales, Dingle, South Kerry. So wherever you're joining us from, I do hope you enjoy the session tonight. Without further ado, I'm going to introduce John Flannery and ask John to give us his thoughts on the night sky for the month of January. And again, to echo Lucy's, thanks to you all for joining us, and your participation, your involvement makes it all worthwhile for the people who are actually putting these things together. So thank you very much. John?
Thanks, Steve. Happy New Year, everyone. I'm just going to share screen here. So should be able to kick off the notes for the year ahead. In fact, it's going to be quite an exciting year of stargazing over the next 12 months. A couple of eclipses to look out for, the usual meteor showers, and on December 8th, Mars plays peekaboo with the moon, where the planet is hidden by the moon or occulted, and that's an event that astronomers are going to eagerly look out for. But tonight we'll focus on the wanderings of the planets during January and talk a little about a star. I know I'm just back from the States, but it's not the Hollywood kind of star I'm going to talk about. It will be the life of the stars we see in the night sky. Ben mentioned seeing Mercury earlier this evening, and it's on view in the southwestern sky at the moment, as the twilight begins to fade from the sky. You should spot it. It's quite a bright spark, and in a few days' time, it will be reasonably close to the planet Saturn, which is also low in the southwest. So the pair of planets together, one will be a guide to the other. Mercury should be on view up to around the 19th of January. But your best opportunity to catch it is over the next maybe week to eight or 9 days. Jupiter remains on view for a couple of hours after sunset. If you have a clear sky and there's a window near you and you're looking towards the southwest, have a peek out tonight and you'll see bright Jupiter to the right of the crescent moon. It's a really beautiful sight. And the moon will, of course, move on tomorrow night and get further away from Jupiter. But Jupiter is the brightest object towards that direction at the moment. So it's unmistakable, and any instrument will reveal either the moons of Jupiter, or with a telescope you can see the banded nature of its atmosphere. But in the morning sky, Venus has departed our evening sky. Well, it's kind of hanging around another day or two. Observers in more southerly latitudes can spot it for a little bit longer, but it will soon pass between us and the sun, an event what's called inferior conjunction. But after it passes between us and the sun, it reappears in the morning sky, and it will soon get rise to prominence. Again, it's the brightest planet and it's unmistakable. The screenshot here shows the view at the end of the month at 6 a.m. when the crescent moon will be near Mars, Venus to the left of Mars, and then very low down, rising just shortly before the sun is the planet Mercury. So it's a nice opportunity to catch Mercury maybe in the evening sky now, and then at the end of the month catch it in the morning sky. But it will be very low, and possibly you might need to use binoculars to spot it just before the sky gets too bright with the oncoming sunrise. In fact, if you are looking with binoculars, be very careful not to look close to the time of sunrise, because you might accidentally sweep up the sun in your field of view. But Mars is still somewhat dim because it's quite distant from Earth. In a telescope, it looks quite small. But as I mentioned, the end of the year, December 8th, a date to circle in the diary, because it's when Mars is at opposition or at its brightest for 2022, but also it's the date that the full moon that day passes in front of Mars or hides it, and it'll be an absolutely spectacular sight. And fingers crossed we don't have the dreaded clouds that night, because so start offering up the novenas now for good weather. But I mentioned the life of a star, and in fact, if you look towards the eastern sky about 6:30 these evenings, you'll see the constellation Orion rising, and the whole area of this part of the sky, the stars look like jewels scattered on the velvet backdrop of night. In fact, I was reading a book that Steve gave me, local man from Ballinskellig's, Michael Kirby. His book Skellig's Hall. There's a poem in it called "Who Scattered the Stars," and I just think these lines are very apt. It is time to scatter the stars, time to light 1,000 billion lamps, to pebble dash a beach, wood a forest, and flow a river. Time to wonder, time to ponder, time to stand in awe, trying to understand who scattered the stars. And the stars do appear to be strewn across the sky randomly, although we've categorized them into constellations. When you look at the winter sky around Orion, we're actually looking in the direction of what's called the Orion Arm, one of the spiral arms of our galaxy, and the sun resides on the inside edge of the Orion Arm. So these stars of Orion and the other groups like Taurus and Gemini are not actually very far away in terms of stellar distances. And they're also quite bright because this whole region of sky is a hotbed of star formation. In fact, this whole region of sky is where you can trace the stellar evolution from the birth of a star in the nebula that can be seen just below the sword of Orion, or the belt of Orion, to Betelgeuse, the orange star is in the upper left shoulder of Orion and is a star near the end of its life. The Orion Nebula is where new stars are forming, and this stellar nursery you can even see in binoculars. In fact, you can see it with the unaided eye as a hazy patch of light, just a very faint hazy patch of light, or what looks like a nebulous star below the three stars that mark Orion's belt. And this is the nebula. When you take a photograph, the pinkish colors is due to hydrogen gas. And then when you look at Betelgeuse, you're looking towards a star that's 1,600 times wider than our sun. If you replaced our sun with Betelgeuse, it would extend out past the orbit of Jupiter. It's truly a ginormous star. It's a star that's racing through its supply of nuclear fuel at a prodigious rate and will eventually end its life as a supernova. And essentially what will happen is when that star explodes, it scatters material back into interstellar space to make the next generation of stars. So the universe, in a sense, is very good at recycling, and that's what we're seeing here. Dead stars being recycled into new ones, and when they die, the cycle starts all over again. In fact, our own sun is possibly a fifth generation star, that the material in our solar system came from previous generations of stars. This diagram shows that idea of recycling. Stars are forming in a cloud of gas and dust that has begun to collapse, possibly prompted by a nearby supernova explosion, the shock wave compressing the gas and triggering a burst of star formation. The protostars eventually emerge from that cloud of gas and dust and either settle down into rather long life, like a sun-like star, which lives for about 10 billion years, or if they've grown quite big, they go a different direction. A massive star burns fiercely, burns its fuel at a very quick rate, and soon evolves into a red giant. Our sun, for example, a life cycle of 10 billion years. A star like Betelgeuse, 10 million years. So just a blink of an eye in the cosmic timescale. Those supergiants will ultimately will go supernova and eventually evolve either into a black hole or a neutron star. Our own sun will evolve into a red giant, puff off its outer layers and form what's called a planetary nebula. And at its core, is at the center of the Planetary Nebula is the core of of the dying star. Essentially, it's the part that will become a white dwarf and eventually wink out of existence. But all this takes place over a long period. And how we came to understand all this is basically through observation, by looking at lots of stars at different stages of their life. You can piece together the life cycle of a star. What is a star? Well, if you strip away the layers of our sun and could look inside, you'd see that it's got the core where there's huge pressures and extremely high temperatures that lead to fusion of atoms to take place, and energy is released in the process. A star is a big ball of plasma, essentially, where atoms have been stripped of their electrons, and this creates an electromagnetic field. So the whole system is quite dynamic, and the energy released in the core keeps the outer layers of the star inflated. Essentially, a star is almost like a struggle between gravity trying to cause it to collapse under its tremendous weight, but then the radiative pressure coming out from the core keeping it inflated. Eventually, as the core begins to dim and eventually grow cold, well, cold in a relative term, there isn't that radiative pressure to keep the layers supported. And in the case of a massive star, gravity wins out, the star begins to implode, rebounds off the core, and the shock wave tears apart the outer layers and gives you a supernova explosion. It's not as dramatic an effect in a star like the sun. It'll just puff off its outer layers and contract to the white dwarf stage. But by studying our sun and the processes that take place in the sun, we get an idea of what happens with other stars. And the sun is a good laboratory for testing our theories about stellar evolution, and not just how our own sun will evolve, but by testing the theories with our own sun, we get an idea of whether they're valid for all the other stars we see in the sky. When stars form in gas clouds, they don't form by themselves. They're not solitary. Previously, people believed that stars would form as single objects or maybe a binary pair, but modern theories show that all stars are formed with a family of other suns. Those gas clouds contain enough material for 1,000 to 2,000 stars, and what's called an open cluster evolves out of these gas clouds when the gas is dissipated. And one example is the Pleiades, the beautiful star group we see in the winter sky. You can find it just by following the three belt stars of Orion to the upper right, through Aldebaran, another orange giant star. And then you come to what looks like a tiny version of the Plough, and that's the Pleiades. And binoculars give a really fantastic view. The gas that surrounds the Pleiades stars is really only teased out with photography. In fact, this isn't the gas cloud that the Pleiades originally formed in. It's a dust cloud they happen to be passing through as they're orbiting the galaxy. And they just are illuminating the neighborhood of space as they're passing through this particular area at the moment. The group is about 445 light years away. So the light we see tonight is roughly left that cluster about the same time that Galileo first turned his telescope towards the group and revealed them to be not just the 6 or 7 we see with the unaided eye, but lots of other stars in the surrounding area as well. So it's quite a sobering thought that when we look up at the Pleiades tonight, we're seeing them when Galileo was alive and making his discoveries that changed astronomy forever. They're bound together still because there is a young group, about 300 million years old. But over time, the gravitational force of our galaxy will disrupt the gravitational bonds of the stars of the Pleiades, and they'll begin to go their separate ways, just like Earth families do. In fact, our sun was probably part of a group like the Pleiades, but because the sun is around about 5 billion years, the cluster it formed in has scattered around the galaxy. Our siblings have gone their own separate ways. And there is a branch of astronomy called stellar archaeology. Using data from the Gaia satellite, they've found a few candidate stars that seem to have a similar chemical composition to our sun, so they may be siblings of our sun. We've gone around the galaxy about 20 times since the sun formed, so it would be difficult to track down any companions of the sun from when it formed, but they're looking in the Gaia data and they may have found a few candidates, but the jury is still out as to whether they're genuine or not, but it would be quite exciting to find them. And it's another area of astronomy that is quite interesting to follow and read up about. And just to wrap up, I came across this piece on a Twitter feed, which I think nicely captures the context of stars and that we are stardust, because that material, when Betelgeuse explodes and it scatters material into interstellar space, and it begins, like a dust cloud begins to collapse and form a new sun, it will bring together all the material to form the next generation of stars, the next generation of planets, and the next generation of creatures that would walk across the surface of that planet. And so another good quote comes from Lawrence Krauss, the astronomer Lawrence Krauss. He once said, "Take a look at your left hand and take a look at your right hand. The atoms in your left hand probably came from one star, and the atoms in your right hand came from another star." And when you think about it like that, it really puts everything in context, that we are all part of the cosmos. We'll go back into the cosmos when the Earth and Sun fade into obscurity. And I always like to think that protons have a very long half-life, in fact, longer than the universe has existed. And protons were formed just after the Big Bang, and they are in the atoms in our bodies, and these protons have essentially been around since the Big Bang. So we have material in our bodies that's 14.5 billion or 14 billion years old. So I sometimes like to say, if someone asks me my age, I just say I'm actually a lot older than you think I am. And it's just when you put it in context, the fact that as the lines there say, we're all just stars that have people's names. It really puts everything in perspective. And just to wrap up, that's a few other events that are happening during the month ahead. I'll copy that link at the top into the chat, but essentially it's a calendar I do every year that's free to download online, and it gives details of all the events occurring in the night sky, along with lots of other astronomical items. But certainly, I'll throw the link into the chat, and feel free to download it and share with anyone you know. So thank you very much, everyone.
Thank you very much, John. As ever, the information you've given us is just quite extraordinary, and
Thanks, Steve.
I think I now realize why at my age I'm very stiff and old. I'm even older than I thought I was getting out of bed this morning. We'll maybe Orla will deal with some questions later on. John will come back to those.
Sure.
Folks, one of the joys of doing this these series are the people we get to hear and meet, and you're about to hear from a pretty extraordinary young man, Ben Porter. Check out his website, benporterwildlife.co.uk. This is a guy who's interested in getting people out, not just for dark sky activity as we would be, but just to get in touch with nature. And I'm really looking forward to his talk. Ben worked with the Live project as a knowledge gatherer, and his photography skills alone would be enough to justify his talk today. I'm really looking forward to it. Ben's joining us from Wales, and we wish you a very hearty welcome, Ben. Thank you.
Well, thanks very much. Yeah, thanks for that introduction. No pressure. Well, yeah, brilliant. I'll just share my screen with the presentation and get cracking. Thanks so much for that talk just then, John. That was absolutely brilliant. Really
Thanks,
enjoyed
man.
that.
Thank you.
Brilliant. Can you guys see that?
Looks good, Ben. Yeah, perfect.
Brilliant. All right, I'll dive on in. So yeah, thanks a lot for having me on this event. I'm just going to give a brief sort of like 10 or 15 minute overview of a sort of region that's very close to my heart in many ways, both geographically and in terms of the species that I'm going to talk about here. I'm a young naturalist, ecologist and wildlife photographer from North Wales. And I'm currently looking at trying to develop some research projects that are very, very aligned with a lot of the elements that I'm going to be talking about in this presentation, and do link in quite closely with dark skies. So I'll dive on in here, and hopefully if you have the volume on your laptops, you'll be able to hear these intriguing sounds. Some of you may have to turn the volume up a little bit. It's a little bit of a quiet recording, but these bizarre sounds, I'm not sure if some people may well recognize them if they've been to some of the offshore islands off the west coast of Ireland or here in Wales. But the species producing these bizarre sounds are these little fellas here. So this is a seabird called the Manx shearwater. Pictured here in its preferred habitat at night. It's a nocturnal seabird which usually visits its colonies under the cover of darkness, and you have them both along the western coast of Ireland and here in Wales, where I'm based on the Llyn Peninsula. And here's a bit of an overview of the species. So the Manx shearwater, or Deryn Druckin Manaw in Welsh, It's what's called a procellariform seabird. So it's in the same group as albatrosses and storm petrels, these seabirds which have tube noses basically that sort of links them all together in this order or family. And these tube noses on their bills are used for excreting salt. So they can essentially get their sort of water content from their prey, and from the seawater, they're able to excrete salt through their beaks. They're an absolutely incredible group of seabirds, one of my most favorite sort of birds in the world. And I'm sure a lot of people have always looked at pictures of albatrosses and seen them on all the different documentaries and just been gobsmacked by them, unless you've actually seen them yourself, in which case I'm sure that would be incredible. But this species, the Manx shearwater, breeds across all the North Atlantic and spends its winters off South America, and islands in the UK particularly are actually really important in a global context for this population. Here in Wales alone, we have about 40% of the global population which return to a scattering of islands in the Irish Sea to breed every year. And one of those is somewhere where I spent half my life growing up, on a small island here in North Wales. So these species are highly nocturnal, as I mentioned before, and they breed in burrows underground, a bit like puffins do, where they raise their single little chick through the spring and summer period, which fledges in the autumn. And they're an incredibly long-lived species. So the oldest wild bird in the world previously was a 54-year-old Manx shearwater, which was caught on the island and that I lived on, and was monitored through its life using a little metal ring, the sort of rings that we put on birds to look at where they go and how old they live. And you can also see in this image here that they sort of like live up to their name in terms of shearing the water. You can see it delicately dipping one wing into the water there. Absolutely spectacular birds. So briefly, before I go on to the sort of dark sky element in this, the Manx shearwater plays a very, very close role in my life after living on this island here, essentially, or Bardsey Island off the Storm Peninsula in North Wales. And this island is home to at least 25,000 pairs of these birds. So you can just imagine the sound that they produce in the full breeding season in springtime. It's an absolute incredible cacophony to hear. And this island where I used to live holds it's the fourth largest colony in the world. And it's where I really grew very passionate about the natural world, became very engaged in wildlife and conservation and studying nature. And it's also where my sort of research and fascination in seabirds began. So during university, when I was studying at the University of Exeter, I actually did my sort of undergraduate dissertation project focused on these amazing seabirds, initially focusing on finding out where they go during their foraging trips. So putting GPS tracking devices on mounting them on the feathers on their back, and then letting them go. This is all done under license, letting them go. They go on a foraging trip and come burrows and they're breeding, and then you delicately get the device off and find out where they've been finding food, where they've been going out at sea. And you can look at where the important foraging sites are and where they're overlapping with potential developments or threats out in the oceanic environment. It was an absolutely fascinating project to do, but was incredibly hard work as well, because you basically have to be out in the colony all night long waiting for these birds to come back with the tags before you can get the data. And this plot of a map of the UK on the right here, you can see all these squiggly lines are basically the tracks of about 20 to 25 Manx shearwaters through the breeding season where they've gone and been foraging. And you can see some of them going all the way up the west coast of Scotland to Rum, where the largest colony in the world of these species exists. So yeah, absolutely incredible birds. And one of the things that fascinates me most about these species is the sort of navigation and the way that they travel through the oceanic environment. And the way that they do this, studies have more really shown that they're able to use celestial and sun compasses, essentially knowing the locations during different time periods of features like the sun and stars in the sky, and being able to use them to navigate, just as one of many different techniques that they can use. Obviously, it's not always clear, so they have other means as well, but it has recently been shown that they do actually draw on celestial features to navigate through these often featureless oceanic environments. But the thing that I'm mainly going to focus on in this talk is their relation to the sort of dark night skies and the effects of artificial light, because this is an increasingly sort of growing area of research and is something that is very pressing and very important to find out more. So Artificial light at night, otherwise abbreviated to ALAN, which is quite a funny abbreviation. But yeah, artificial light at night is, as I'm sure most people are aware, quite a big issue for a variety of different wildlife species that depend on, you know, really dark night skies for their breeding biology, for their behaviors and all other manner of things. And seabirds being, well, these particular seabirds being nocturnal seabirds, are quite sensitive to artificial light at night. In particular, one of the biggest effects that artificial light has is during the fledgling period, often in autumn time. So taking the Manx shearwater, for example, it's been shown that whilst adult Manx shearwaters aren't too prone to being attracted or disorientated by artificial light, the key thing is that fledglings don't fully develop their sort of eyesight and sort of navigation abilities until many weeks after fledging the nests. And so in the first few weeks after coming out of their burrow underground, their eyes take a bit of time to fully develop because they've been underground in a burrow for most of their life. And so in this period after fledging, they're really prone to being disorientated by artificial light sources. Usually these burrow nesting seabirds will come out of the burrow and they'll seek maybe slightly brighter areas of the sort of landscape or seascape, essentially, because they'll follow the sort of generally reflective color of the sea to go out to sea to safety. But obviously with human sort of developments and all things along the coast, you often get quite big sources of artificial light which can disorientate these fledgling seabirds, which then head to coastal towns or cities and bright lights, things like lighthouses as well. They can end up specifically under different weather conditions attracted to these lights. Just on Bardsey Island itself, where I used to live, on particular nights in September when these shearwaters were fledging, if you had really foggy conditions which sort of like amplified the effect of light and the inability of them to navigate, you could get thousands or maybe hundreds at least of these young shearwaters sort of flying to the lighthouse, sometimes hitting the tower itself. But a lot of the time, because we were on hand to draw them back down to the ground, we were able to save quite a lot of them. Here's a very fluffy late stage Manx shearwater chick on the right here, which we gently got out of its burrow for the purposes of some study work. And you can see that they do get very, very fluffy and very fat. Some of them have to slim down quite a long time after their parents have left them before they can actually leave them. So in terms of the effects that artificial light can have on these nocturnal seabirds, these fallout events in autumn are particularly of concern and recorded all across the world, as I'll mention in a sec. And in addition to that, not just the fledglings are affected, you know, artificial light around colonies can really disrupt the adult behaviors as well when they're coming in and out to the nest. It can cause them to sort of not visit the colony quite as much because of fear of light. In that sort of context can be a much more disadvantage for getting predated. So a lot of shearwaters that are really sensitive to artificial light and just light in general, they won't actually visit the colony during moonlit periods because they're more likely to be predated. These seabirds are really clumsy on the ground, and so they're really vulnerable to land-based predators. And so they don't generally visit the colony when the moon is really bright. And so that sort of effect is confounded when you have like big artificial lights around these areas. And so it's something that really has to be looked at and sort of worked out to sort of mitigate the effects of this. But it's worth mentioning that sort of the specifics of the sort of wavelength intensity of light have a big effect. And so sort of really bright white and yellow lights have the biggest effect of attracting these seabirds, because things like red and blue and green light aren't as sort of like attracting to these species. And it's still being researched, the sort of elements of this, so that we can best adapt lighting setups in different areas to sort of mitigate these effects. And it's still a growing and very under-researched area. And it's not just restricted to these sort of regions that I've been talking about in Wales with things like the Manx shearwater. It's ALAN, artificial light at night, is very much a global issue for seabirds, which are actually one of the most threatened groups of birds worldwide, seabirds. And these nocturnal seabirds, the Procellariforms, are particularly vulnerable. This image in the middle was taken when I was doing some seabird research work in the Azores, and you can see that, you know, the sky glow effect of the developments and the sort of coastal town on that island opposite, massively illuminating the clouds from below. And just offshore, we're living on a small island here where you have Kerry shearwaters, the species on the left, and many other really important storm petrel and shearwater species. And again, you know, in the autumn periods when the fledglings leave the nest, you often get big numbers of these shearwaters turning up in the towns, attracted to these really bright lights, because often they nest in coastal areas, and you often have, particularly in places like Canaries, the Azores, and places in the Mediterranean, you often have this crossover with really big coastal developments for sort of tourism and people living there, and really bright lights. And so that sort of combination could be really damaging to these species. But the good news is that there is actually quite a lot that can be done about it. I didn't mention there, but actually, like in West and Southwest Ireland, because like shearwaters nesting out the Skellig Michael and the rocks out there and the islands out there, there are actually sort of like campaigns underway across Ireland and other areas of the UK where these fledgling birds that turn up in towns and villages sometimes in the autumn, these disorientated little things, they're often picked up and people phone in a sort of hotline of like then getting the rescue campaign and sending these birds back out to sea. But in terms of mitigating these effects of artificial light for these really important seabirds, and there are a few things that can be done. So this image here, this panoramic, was taken where I used to live on Bardsey Island off North Wales. And actually it's interesting in itself just to look across the horizon there, where you can see all these sources of light pollution from urban areas down Cardigan Bay. And even on the right there, I'm silhouetted, I kid you not, against the lights from Dublin, which just shows 45 miles away, you know, it still has quite a dramatic effect on the horizon there. But you can see down below me, the red light coming off from the island there, that's actually the lighthouse, which in 2014 was changed from this really intense, really bright sort of yellow-white light that was rotating on a massive lantern in this sort of lighthouse. It was changed to a red LED in 2014, and it's still visible from a really great distance, still really bright, but we no longer have things like shearwaters attracted to the lighthouse in the autumn or during any other time of year. So this change of wavelength has had a really massive effect, and means we no longer get any birds flying into the tower, no more mortalities or anything, which is absolutely fantastic. And I think it'd be really great to roll this sort of like example out to other areas. And I know other places have also changed to red LEDs, but thinking about offshore, for instance, wind farms and other developments that take place actually in the marine environment, trying to adapt sort of lighting setups that use things like red LEDs to minimize attraction of seabirds is something that really needs to be considered and is being looked at in terms of like policy level as well. Dark skies reserves obviously is a very topical point that has a big effect. So obviously in some really sensitive areas, well, we should have dark skies reserves in many areas, but in it sort of the sensitive areas where seabirds such as this exist, it makes even more sense to try and protect those sort of dark sky areas so that you have few impacts of bright lights attracting seabirds in. And Bardsey Island itself is now in the process of being designated as a dark skies reserve, which is really exciting. And opposite here on the mainland, not far from Iveragh, sort of small village on the tip of the peninsula, we're trying to get dark sky status for this area here as well, which would mean that we'll have greater ability to sort of talk to, you know, sort of groups or individuals or companies that have really bright lights on their buildings and everything, to look at other ways, shielding them, having different wavelengths and that sort of thing. And this all has a really good effect for preserving our dark night skies, and obviously then having better effects on behaviors of these really important species. And for areas where you still get these sort of fallout events and where birds are attracted to lights and end up in really dangerous places where they can have increased mortality, there are SOS, as they're called, campaigns in various places around the world, the Save Our Shearwaters. And these campaigns basically bring together groups and concerned individuals together at specific times of year to go picking up these birds that end up in towns and villages in the middle of nowhere, where they often get picked up by cats or even run over, you know, things like this. And you basically, you know, rescue these birds, see if they're still in healthy condition, maybe give them a bit of fish and feed them up for a few days before they're ready to go back out to sea, and then you carefully release them. And a lot of them do survive, but these awareness campaigns as well can raise awareness of the need to reduce, you know, bright lights and change lighting and everything. So it's a really great thing, really powerful for bringing together communities to, you know, raise awareness of the amazing seabirds that we have, you know, along our coast as well. And there's a lot more research also that is needed to look at which species are particularly vulnerable and why they are, and where is particularly bad for them being affected by these things as well. So within this sort of sphere of like seabirds and light pollution, I'm actually currently developing plans for a project that will be looking quite sort of in depth at this issue in the Northeast Atlantic. So I'm hoping to get up to the Faroe Islands and begin a PhD project studying the effects of artificial light on various offshore marine developments and how it's affecting these really important species. The Storm Petrol is another Procellariform, so this little tube nose seabird. You can see on its little bill there in the corner, it's got that little tube nose on it, and they're remarkable birds. You know, they weigh as much as a house sparrow, but they spend all their lives pretty much at sea and just return to colonies like this, nesting in amongst the boulders and the grassy slopes here on the Faroes. And we don't know anything about how they interact with artificial light, and nor even where they go when they're offshore. So we're trying to reveal a little bit more about their sort of marine at sea lives and how they're affected by these issues, really. So I'm hoping this year to get fully funded for a PhD starting out there. Last year I did a bit of a pilot study in the summer, which was fantastic to see these colonies at night. It really is something else. If you've never been in a seabird colony at night, hearing the sounds and seeing these ghostly figures coming over, I'd really recommend trying to get out there. It's absolutely wonderful, especially obviously if you have the dark sky and the starry night sky in the backdrop as well. It's pretty breathtaking. So that was a bit of a sort of the general topic of sort of light pollution and seabirds, but hope you enjoyed. Yeah, if you have any questions about these things, just pop them in the chat, and I'm sure if we've got time, hopefully be able to answer them. But yeah.
Thanks a million, Ben.
Yeah, that's fascinating.
Fascinating, yeah, well done.
Yeah.
Brilliant.
And it's lovely to hear about what you're doing since you stopped working with us. Excuse me, I'm a little bit hoarse. So we do have some questions in the chat, and I expect people have their own questions still. So other people, please do join in. And lots of very nice positive comments for both of you in the chat as well. The first question that we had a while back is a very technical one for you, John, about how large the Pleiades cluster is.
Yes, an excellent question. In fact, it had me scurrying to I found an article about the Pleiades in the PDF copy I have of Sky and Telescope magazine from 2019. I'll just get the exact month, but it was generally about the distance to the Pleiades cluster itself, because the previous mapping satellite Hipparchus that preceded Gaia gave a distance to the Pleiades that was less than what all the observatories around the world were deriving. So they thought there was something wrong with our models of stellar evolution and star distances, but Gaia corrected the issue. But it was March 2019 issue of Sky and Telescope magazine. But the Pleiades themselves, there's roughly about 1,500 stars in the cluster. So it's quite packed. So binoculars will show several dozen stars, and binoculars are really the only instrument to view them with, because they're so spread out that if you look at them with a telescope, you're only seeing a portion of the group. But the distances between the stars, there'd be a couple of light years between each star, so there's no danger of collision. Now, a planet going around a star in the Pleiades would see a sky at night that had many bright stars scattered around it, but they wouldn't be no brighter than maybe what the star Sirius appears to us. On the other hand, there's another class of clusters called globular clusters, and these are swarms of maybe 500,000 stars that are arrayed in a halo around the Milky Way, and a planet going around the star at the center of a globular cluster would never have a dark night sky. The sky would always would appear twilight, and you'd see several hundred stars about the brightness of Venus in the sky of a globular cluster. But the Pleiades, it's a pretty dense star group in its own right, with about 1,500 members. But there is a reasonable distance between them.
I think certainly during all of the stargazing sessions that we do, one of the things that is quite incredible is the reaction people have when they see the Pleiades in binoculars.
Yes.
And anybody, if you do get a clear night, especially at the moment with Orion, very easy to find, straight out along the line of Orion's belt, out past the big star, Aldebaran, and out a little bit more, and you suddenly see this cluster. And on Nullig Naman, it's the most impressive engagement ring you're ever going to see. It's really beautiful.
Lovely. Anna Brennan, you have your hand up, so I'm going to click the button to allow you to talk. If you'd like to ask a question, you can just speak away, and we should be able to hear you.
Apologies, I think it's up in error. I enjoyed it. Thank you very much.
Do you want to make any comments?
Yeah, no, the talks were excellent. Thank you for I'm really enjoying this series of talks. Thank you.
Grand, no bother. I wasn't sure and I didn't want to let it go. When you said that's the one, John, the Pleiades, that's the one that looks like the tiny plough. Is that right?
Yes. Yeah.
Okay. I think I know that one, but it's kind of it is that the stars are way closer together. It's not a Father Ted thing, but it's just further away, is it?
Oh yeah. Funnily enough, the plough is a cluster as well. It's the closest star cluster to the Earth, but because of its nearness, it appears to us very spread out across the sky.
Okay.
Now, when I say the plough is a star cluster, 5 of the 7 stars making up the plough share a common motion through space, and also are at similar distances from Earth. The exceptions are the star at the very tip of the handle, or the tip of the tail of the bear, and the one in the top right of the bowl, a star called Dufay. Both of them are going in the opposite direction to the other 5, and they're twice the distance. But those 5 are considered to be the brighter members of what's the closest star cluster to Earth.
Okay.
Maybe about 75 to 80 light years away.
Wow. Interesting. Okay, we have really technical questions this evening. Ben, have you spotted the one in the Q&A for you? About, so Emily's asking about how seabirds navigate and if there's evidence of them using quantum mechanics to use magnetic fields for navigation. I'm not even sure I understand that question, so.
Brilliant, that's a good question. I can certainly answer an element of that. So it has been discovered that some seabirds can use magnetic sense, or in fact a lot of birds themselves can use magnetic sense to navigate, and it's one of a number of different elements that they'll use for navigation. Whether they're fully reliant on it or not is up for question. So one experiment was done on some Kerry shearwaters in the Mediterranean and just offshore, where they actually they tried to work out where the magnetic sense might be, and they actually disrupted their sense of smell and released them out at sea, and saw the difference between birds that navigated back to their colony with and without the sense of smell, and those that had their sense of smell sort of like disrupted were much less good at navigating back. So there's sort of like slightly mixed results as to whether they're fully reliant on the magnetic sense or whether it's a combination of other senses. But certainly even species just like the robin is able to navigate using magnetic sense. So it is definitely an element that they use, but it's still very, very much not fully understood. How it works and everything is very much, up for question.
There's another question here for you, but did you read, there was a book, Ben, out a few years ago, was it The Seabird's Cry?
Yes, Seabird Cry, yes.
That was
Brilliant.
a good one for anyone who's interested in some of those things. Some of the experiments were horrific, but very interesting. And very readable for anyone who's just kind of casually interested as well. There's another question then here from Katrina about the light from lighthouses also disrupting birds in Ireland, which yes, it does do. And do you know if there's any move to change them here? I don't know about this, and I don't know if any of the audience do. Do you have any ideas, Ben?
I don't personally know. I'm not totally sure along the Irish coast. I know I've got a friend who's been working out on some islands. I think, which ones would they be? They're further north than Kerry, near the Burren.
Maybe the Aran Islands or
yeah, something like that. And they're looking at sort of like creating a bit of an awareness campaign over there. But I'm not actually sure what prompted. Trinity House own the lighthouse on Bardsey and a lot of lighthouses around the UK. And I'm not, they say that actually it was the sort of the occurrence of lighthouse attractions and things that led them to change to a red LED. But there wasn't much sort of like consultation about it or anything. They just sort of did it. And then it was like, oh, wow, this has a massive effect. But it hasn't been rolled out to many other lighthouses as yet.
But it is still a functioning lighthouse. Like it is.
Exactly.
It is
No, it's definitely, I don't know if anyone can comment on whether anything, I don't know how it works with the sort of like the planning permission and things along there, but
they're all owned by the one group. Probably a final question then for you, Ben. When do the shearwaters migrate to Ireland and Wales, and when do they leave?
Yeah, well, that's exciting. Only a couple of months to go, so they usually arrive sort of, in fact, with a new moon, usually under the cover of darkness in sort of mid to late March. The first ones will start arriving, depending on when the new moon is, and then they'll leave. The fledglings usually leave the nest as late as early mid-September and then head back down to South America. So hopefully in the next, mid-March, hopefully they'll start returning. You'll see them out at sea, and then if you're near a colony, you can hear them there as they return.
Lovely. Yeah. Fantastic. I think that's us for the evening then. And we do try and we'd like to try and let you all get away before 9. Steve, is there anything else before we wrap up?
No, other than to maybe at some stage get Ben over here to experience again South Kerry, and if we can organise something. My hope is with COVID kind of hopefully diminishing in terms of impact, we'll actually get people together and on a beach looking at stars and hearing birds and getting input in real time. It would be lovely to do. Again, to thank John and Ben for the wonderful talks. As I said earlier, one of the great parts of this is to just hear what people are doing and the knowledge that's out there. It's stunning. Just thank you.
Yeah.
Just as you were talking about seabirds there, Ben, there's a podcast from Birdwatch Ireland called In Your Nature, and they have a podcast about seabirds, but they're talking to the wardens on Rockabill off the Dublin coast, and they have a piece about the Storm Petrol as well.
I'll check that out. Thank you. That sounds great.
Brilliant. Thank you so much, everyone. And as Steve has said, for being so generous with your knowledge. And we'll be here again next month. And hopefully we'll see lots of you back here again too.
Yeah. Thanks everyone.
Thanks a lot. Yeah, take care.
As ever, Orla, thank you. Cheers.
Take care. Bye.
Thank you, everyone. Slán.
Slán.